And this is another edition of 3D Printing News Unpeeled, courtesy of 3dprint.com. And our first news for today is that Wayland Additive is making more machines, which is quite a remarkable achievement. The young British company has made its new beam or electron beam melting technology available only very, very recently. Its first customers were in 2022, sold 2 customers that are public, the Royal Air Force and EWI. And now it's producing 6 machines in one go. And it hopes to have 10 machines ready for customers or shipped to customers by the end of 2023. And in 2024, it wants to build 24 machines. So this is, again, remarkable achievement to make something as complex as an Ebeam machine so relatively quickly. It's going to be very difficult for them. These things are basically as hand-built as, more hand-built than your dream sports car. And they're much more complicated as well. And there's a lot of tolerances involved that your sports car probably does not have. So this is a remarkable achievement, and we're in the midst of a kind of an e-beam or electron beam renaissance. So we've got JOL from Japan, we've got Weyland from the UK, we've got other companies out there experimenting with the technology, and so on the whole, there's a lot more interest now, a lot more interest on the OEM side of people wanting to sell these systems, from Freemelt making like a kind of like a system for your lab, to Wayland one to give you kind of a production system, to people working on much larger systems as well. So this is great for the technology, great for us all, I think, because E-beam has always been kind of the unloved stepsister to powder bed fusion. Powder bed fusion has been, laser powder bed fusion has been a much bigger club with more members, with more companies, more researchers pushing it. And E-beam has been much more of a niche activity, essentially for a long time being confined to RCAM, which is now GE RCAM. But it's a ridiculously productive technology. If we think of additive as making the shape in the machine and the part in post-production, things like hip cups and other orthopedic implants are just simply cheaper with this technology than anything else in the world. And things like some aerospace applications as well, like turbine blades and stuff, are also better to be made on the E-beam for various reasons. We can also make gradient parts. We can make some really exciting kind of metals that are really difficult to make with other technologies as well. So this is really another tool in our tool belt, and it's good that we're seeing young companies bring it to the fore. So the Caliber 3 machine means that the demand for this machine means they've doubled the site, and they've done this at a really remarkable time. I mean, imagine selling, this many machines, and imagine getting in those orders and pushing the machines and the software out the door. Now, of course, we all know that someone's first machine, it's always going to be problematic. I mean, it doesn't matter what company you are, how good you are, what you do. It's the first machine is going to be it's going to be problematic. A friend of mine who's a fashion designer said that in fashion design, they have this thing called the pancake collection, that you kind of, your first fashion show, first collection is considered to be kind of like a pancake. Like, it never really works the first time. And 3D and additive, it's for your first machine is always going to be very problematic. You're always going to find things out at the customer site that you haven't thought of, or certain things that you didn't get right. So, for that, for us knowing that, and then to be able to scale with such a complex system to production so quickly is a remarkable achievement. So that's wonderful. And it's a really good machine to have at this moment, because the UK is now investing heavily in its defense capability, its additive manufacturing for defense, and in UK-based businesses. So this is, a very, very wonderful time. So the next thing is a heart model. Now, we're seeing a lot of these phantoms and heart models and organs on a chip come to the fore, and always they're kind of people are not as excited by them. But by having a model or a phantom to help people educate themselves, help surgeons plan things, help students learn, help researchers learn, that is really a nice interim business for us to have. I mean, while we figure out how to print the things better, but also it's something that makes research much faster, more accurate, and cheaper. So it's wonderful. So MIT has a student called Luca Rosalia, who, together with a football team of other people, made a soft, flexible 3D printed shell that mimics the heart's pumping action. What they can do is attach kind of pneumatic things to it, and then they can mimic certain problems of the heart or certain functions of the heart. So on the one hand, they hope that for certain conditions, they can use an individualized heart model for you to test on your heart what would be the best intervention, what would be the best kind of way to approach a surgery or something like that. And just generally, researchers, universities, companies developing products can use this model to test like the flow and functioning of the heart. So it's a little bit better. I'm putting it out there because like these things are always not as popular as we 3D printed a heart tissue or something like that. But this could be a real boon to researchers and the researching community as a whole. And the last thing is Seer Marine. So Seer Marine is a UAE-based company that we've talked about before because they bought a giant CAD machine, and they were going to, it's one of the largest additive machines in the world, and they were going to use it for boats. And at the time, I mentioned in the article and things that I thought that the main thing is USVs. And the first thing they really made with it, they showcased, was unveiled, and that is a USV called the Hydra. This is 350 kilogram USV. It's 5 meters in length. The print itself took 5 days. Now, of course, there's a finishing and all this other stuff on that, even though the CAD has, can have multiple tooling heads. But still, there's probably more finishing time on that on the back of that as well. It's meant to be eventually, this is a technology demonstrator, so it's nothing quite yet. It's meant to eventually be morphed into across a couple of iterations, ISR vessel, so an intelligence kind of swooping, patrolling kind of vessel. And I think this is important. And the reason is that we've seen the Americans and a lot of other people invest a lot of money in all these really large format machines. One of the reasons is specifically to 3D print boats and boat hulls and other types of hull type shaped things, also for aircraft. And of course, the current way to making polymer boats with like molds on fiberglass is very environmentally unsustainable, but at the same time, it's very slow and very manual labor intensive. So here we're seeing a process that can directly have you print the hull without a mold, have you iterate much faster, but also produce these craft at a much higher rate. And this is a huge, huge thing because this means that you can now make maybe, dozens of ships a month. Right? Think about how long, many years and many millions it takes to create a big surface ship, and now you can put a kind of kamikaze suicide ship up against it, which is probably happening, by the way, if it hasn't already happened in Ukraine. But it's definitely going to happen in the future. The USV is going to be a more fundamentally interesting, more fundamentally revolutionary thing in sea warfare than the UAV is going to be in air warfare. It's going to have a much, much bigger impact. And the reason for that is that you can have a flotilla of these things, print out 5 new ones. Let's say you can make 5 a day. You can then automatically make 5 a day and keep adding that flotilla. And that flotilla could act like an area deniability weapon. It could be a very sacrificial type of weapon. It could be a weapon that in a swarm, they race for a much bigger ship. Right? They could be continuously improved depending on the conditions, depending on if the other guy evolves his tactics or his practices or his kit, you can get better. And what you can do is you could, for example, have giant flotillas of thousands of these craft floating around instead of a carrier group. Right? You could send one ship to a foreign country to patrol its coast, and that ship could be, it could be sunk and you couldn't care. So putting people at risk is always the biggest problem, because if you put a carrier group someone, you're all of a sudden somewhere, you're talking about dozens of aircraft, thousands of sailors at risk. Yes, you're projecting power, but there's also a risk there on your side, which you saw with the USS Cole and other incidents. Now here, you've got a craft that no one is on it, right? So it makes you much more able to carry out a war or a strike somewhere. You could put a cruise missile, a SLAM missile on this thing, and then all of a sudden you can reach out and touch someone 200 kilometers inland from anywhere on the sea in the world. Right, for literal engagements, but also just like think of this as a flotilla or an ability to project or carry like small drones and project them inland as well. This is really going to completely change naval warfare, completely, totally. And we're seeing the first moves of this. It will take a while for this to percolate through, but this is a huge, huge space, and we will be right on top of it. Don't you worry about that. And that was 3D Printing News Unpeeled. I hope this was useful to you. My name is Joris Peels. This is brought to you by 3dprint.com, and you have a great day.